In this video, we will use the idea of finding velocity using a distance versus time graph. From prior videos, we learned that the slope equals the velocity. And when you have a straight sloping line like we have right here, it's pretty simple. The velocity is going to equal the slope of that line. Because if you remember, average velocity was equal to the change in distance, change in s, over change in t. So if we have two different values here, let's just say this value was time equals 2 seconds and 2 meters. And we'll just go down here and say this is just 1 second and 1 meter. So it'd be a pretty simple calculation. You can figure out that's going to be 2 meters minus 1 meter all over 2 seconds minus 1 second. And your average velocity would be 1 meter per second. And that's when you can go right in and just get a slope of a line because it's straight. Well, we don't always have that situation. Sometimes we'll have slopes that are gradually changing. And in this case, we're still going to use our slope idea, but we're going to find what we call the instantaneous velocity. Or instantaneous speed. That will equal the slope at a given point. So if we're going to find the slope of this point right here, what we need to do is draw what we call tangent lines. So what I'm going to do is I'm going to take my little line tool and I'm going to draw a tangent on there. I'm going to try to do that with this blue line. I'm going to try to make it very, very thin. So if I go from here to here, oh, that's not what I want. Let's try this green one right here instead. So I'm going to go from here to here. I want to try to find a point that's tangent to that. I would say that's pretty close to a tangent line. And then if we take note of a different point up here, let me go back and switch to my pen, we'll see that the slope of this line is different. Okay, I'm trying to use this pink one right here. So this point, this tangent is a little bit more steep. So what does this show us? We could find this by simply using ordered pairs in slope. The bottom line is this has a greater, or not greater, this point right here has less speed. This point has more speed. And what we could do is simply find two ordered pairs on there. For example, and again, I'm going to have to make these up kind of on the fly. This might be like 5 seconds and maybe 10 meters. And maybe over here, if we go just a little bit farther, maybe it's like 7 seconds and 14 meters. And it's not really written as a very well ordered pair, but here's the idea. Our velocity is going to equal the change in distance over the change in time. So it's going to be 14 meters minus 10 meters divided by 7 seconds minus 5 seconds. That's simply going to be 4 divided by 2. And you can probably guess I put simple numbers in there to make it easy on myself, which would be 2 meters per second. So then if we would find the speed at this one, we would probably guess that this should be something less than 2 meters per second. And again, we could use two ordered pairs on this line to find the slope. But because we've kind of just sketched these graphs, I just want to give you the idea. And again, I made up these ordered pairs. They might not be scaled exactly right, but the idea of this is if you can draw a tangent line, you can use the graph to find the two ordered pairs that you would need to get the slope. So looking at a couple other examples, if we have something like this happening, we can see here that the beginning of this is more steep than the last part of this. And again, just drawing in some simple tangents. Right here is the tangent probably at this point right here. And if let's say I want to take the tangent at that point right there, and I go back to my little pink line, that would probably go something kind of like this. So again, when you're looking at the two speeds and seeing what's happening with those speeds, you can see that this point right here is a greater velocity. This right here would have less velocity. And again, if you have an actual graph that you've plotted out, you can use the ordered pairs that these lines fall on to figure out the actual velocity using the slope. And one other thing, it doesn't matter if it's a positive or negatively sloping line. Again, the more slope, the more velocity. So again, if I just find the tangent of two different points, and I'm just going to kind of sketch 2 points on here, I want to find the tangent of this point versus the tangent line of this point. If I take my line tool and just rough a tangent in there, you can see a tangent line here would probably be something like that. If I draw a pink one over here, it would probably be something similar to that. Remember, a tangent's a line that only goes through one point. So again, here I am going to have greater negative velocity. Here I will have less negative velocity. And the tangent lines slowly lose slope, indicating we have less and less velocity.